Good morning, students. Now we are continuing with this chapter recursion, and today we will tell you about GCD, that is the HCF that we have already done in the primary classes in maths. Okay, we have already told, I have already told you about the factorial, and here is the iterative definition of the factorial function. You can see from here. Now let's start with GCD. Now to find the GCD or to find the HCF, we need to hold two positive integers p and q. Now if p greater than q, the GCD of p and q is the same as GCD of p and p% q. Okay, that is, in our Java code we write to compute GCD as, if q equal to 0, then return p, return GCD q comma p% q. Okay, so this is actually the base case. That is, when the value of q will be 0, then it will return p. Now to see the reduction step converges to the base case, observe that the second input strictly decreases in each recursive call, since p% q less than q. So means to end the recursion, the second argument must reduce the value. Now you can see from here. See, I have taken an example of 1048, means 1440 and 408. Okay. Now remember the school mathematics. To find HCF, we need to find the quotient and the remainder. Now we will again do the division of the last number with the remainder of the first division. Okay, so 1440 divided by 408, quotient is 3 and remainder is 216. So we have to divide 408, see this number, with this number. Okay, 408 divided by 216, so remainder will be 1 and means quotient is 1 and remainder will be 192. Now here also you have to divide this last number 216 by 192, so you will get a remainder of 24 and a quotient of 1. Now again you have to divide 192 by 24, then you will get quotient is 8 and remainder is 0. Now coming to the example, see in this example the same thing is happening. See here there is some printing mistake, that is not 24, that is 192. Okay, now after this stage the value of q is 0. Okay, this is 0, the second one. Okay, so it will return p, that is the first one. Remember how we are calling at first, that is first argument is p and second is q. Now in the second time when the function is calling, this is treated as p and this p% q is treated as q. That's why I am telling this thing. So it will return p. Okay, now 24, so it will finally return 24. So the recursive solution to the problem of computing the GCD is known as Euclid's algorithm, and this is one of the oldest algorithm. Okay, next thing is Fibonacci series or Fibonacci numbers. Now I think you have written Fibonacci series and printed Fibonacci number with the help of loop. Now here we will do the same thing with the help of recursion. So here this sequence sequence starts with 0 and 1, which we will think of as the 0th and the first element of Fibonacci series. Okay, and each succeeding element is the sum of the previous two elements. Okay, so first element is 0, second element is 1, then third element is 0 plus 1, that is 1. Okay, then next element is 1 plus 1, that is 2. Next element, that is 2 plus 1 is 3, then 3 plus 2 is 5, then 5 plus 3 is 8. Like that the series go on. Okay, now we want to write a method fib that takes some integer n as a parameter and return the nth Fibonacci number, where we think of the first one as the first Fibonacci number. Thus, invoking fib8 means fib6 should return 8 and the invocation of fib7 should return 13. Understood? See here, I am just calling this fib with n, fib int n. Now if n less than equal to 1, it will return n. Less than equal to 1 means 0, so it will return 0. Okay, otherwise it will return fib of n minus 1 plus fib of n minus 2. So this type of thing is this recursive case, and this is the base case. Understood? Now see, this will be the tree, means it will act as a tree, the calling. Initially we called with parameter 5. Okay, now representing the original method, in the case fib5 there will be two recursive call fib4 and fib3. Fib4 and fib3. Fib4 in turn calls two functions, that is fib3 and fib2. Fib3 in turn calls two functions, that is fib2 and fib1. Now fib1 means one terminating value, and fib2 in turns call fib1 and fib0. Fib1 is also terminating value, fib0 is also terminating value. So this part is okay, and again for the same reason this part is also okay. So fib4 we have already calculated. Now here in the same way, fib3 equals to fib of 2 plus fib of 1. So fib2 is calculated as fib of 1 plus fib of 0. Now fib of 1 has a specific value and fib of 0 has a specific value. So fib2 is calculated, and based on this fib3 is also calculated. Now as we got fib4 and fib3, so we can get fib5. See here, I am just showing you. Just wait for few minutes, means few seconds. Okay. See here, fib5 we have called is fib4, fib3, then fib3 called fib2, fib1, this one, means as I already told you. Okay, in mathematics you have already heard about the term recurrence relation. It is similar to that thing only. Fine. Okay, that much for today.